This is LeetCode 2434, using a robot to print the lexicographically smallest string. This is the daily problem for June 6th, 2025. So we're given a string S, and we're able to do two operations on it. We're able to remove the first character and add it to this other string T, and then we're also allowed to remove the last character of string T and then essentially output it to our result. And so given these operations, we want to return the lexicographically smallest string that we can output. So, I guess the first thing to realize here is that this T string is basically a stack, right? So we're adding to this stack, and then at each iteration we can either add to the stack or we can pop to the stack, and the popped element we can add to our result. So, we have to be intelligent about when we are adding to the stack and when we're popping from the stack. So I think the most important piece of information here would be to know what the smallest element is at each index between the index and the end of the string. So you can think of it as a minimum suffix in terms of the lexicographic size of the character. So you want the smallest character from your index to the end at each index. So the reason that's helpful is because when you are iterating through S, you would look at, okay, is there a character that's lower than the one I'm at right now? If so, we should append to the stack until we get to that character. Then once we've hit that character, we would pop that, put that in our result, and then see if there's any other elements at the top of our stack that are less than the next lowest character in the string from onwards from where we're at. And if so, we pop those and add those. Otherwise, we continue iterating through the string until we reach that element. So some of the test cases that they provide here are not great. So I think this test case is one of the better ones. So this is the string S, right? And the first thing is you want to calculate the min suffix like I was talking about. So you would start at the end and you would say, okay, so the last character is always going to be the same. So we start with E, and then E is less than V, so this is also going to be E, and E is less than F, so we're going to continue E, 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 but then we reach D. D is less than E, so now D is the smallest character from this point onwards, and then D is also less than Y, and then finally we get to here, this is B, so that's the smallest character at that point. So here's our string T. This is going to be our stack, and then they call the result P in this problem, so P will be the result. And so, let's go through the logic that I was talking about, right? So the very first thing you have to do is, of course, append the character to the stack, right? So we put B here, and then we're going to say, when we go to our next character, we're going to say, basically, is this character less than or equal to you know what, actually. So basically, okay, so when we get to, So the first thing we're going to do is we're going to add to the stack, and then we're going to say, is this character less than or equal to the next character in our min suffix string, right? Because if it is, then we know that we've done the best that we can, so we have to add that to our result. So we would see, okay, B is less than D, that's going to be the next one. So B is the best we can do, so we shouldn't, in our next step add Y here. Otherwise that would put B at the beginning, and that wouldn't be good for us, right? So we actually want to add that to the result immediately, because we know that's going to be the lowest character in this string. It wouldn't make sense to put any other character before the B. So we go on to the next character, have Y. Okay, is Y less than or equal to the next character, next lowest character, I should say, D? It is, so let's add that to the stack, and we're not going to pop it. Then we get to D, and we're going to say, okay, D is less than or equal to the next lowest character, which would be E. So we can, add it here, and then back to back, pop it, and then add it here. So we're doing the two operations back to back, essentially. Just look at the next element, I, that's not less than E, so we add it to the stack. Z, once again, F, V, and then finally we get to the last element, E. So once you get to the last element, there's no more elements to check here. So you're basically just going to, whatever's in your stack at this point, you're just going to add in that order. So E, V, F, Z, I, Y, and then this will be your answer. So that's the lexicographically smallest string, and it makes sense because you have the B here, you have the D here, you have the E here, and then at the end these characters aren't necessarily in order, and that was just due to the fact that the operations that we were given means that we have to prioritize these characters here that we can see in the minimum suffix, but the order of the rest of the characters is just doesn't really change at all. So what I'm trying to say is it would be more optimal, right, if we could move this Z, if we could move this Z to the end, but we can't do that. There's just no way that can happen given the operations that we have, where we have to add to this stack and then pop from this stack. So this is the best we can do. This result here is the best we can do. So that would be the answer. So let's implement that logic now, right? So basically the first thing we want to do is we want to create the minimum suffix, right? So I think it's easier to do this with an array, so we'll say for I in range. So we start at the end, and then we go to the beginning, and then we're going to say I guess we can start with the last letter, right? So well, actually, we don't want to be prepending every iteration. So what we want to do is we want to initialize this to be an empty array of size length s. And then what we want to do is we want to say, the last element is just going to equal the last element of s, right? Because these letters are always going to be the same. And then we can start at -2, and then we can say if s at I is less than or equal to min suffix at I plus 1, then min suff I, or actually what's easier is if we were just to do the min, right? So we would do min of min suff I plus 1. So either you keep the letter the same, or if si is lower, then you replace it. And so that logic should give us this string, our min suffixes. And then let's have our stack here, T, and then we'll say for C in S, let's see, I think we will need to enumerate, so we might as well just do this, and then we'll say So I think it's also better to do that as an array. So we'll change that to an array, and then the first thing we're going to do is we're going to append to the stack, append the character to the stack, and then we're going to say while stack, and so either we're at the last element, right? So if we're at the last element, we just want to pop all the elements from the stack at that point. So either we're at the last element, or the I+1 element. So either or our current letter is less than or equal to. I should say that the top of the stack is less than or equal to the next smallest letter. So then we have our result, and then we would add to our result stack.pop, and then we would return the result. Oh, I'm not calling it stack, I'm calling it T. I think I have to, the enumeration works like that. List index out of range, why would that be? Oh, because we're not calling on T, we need to call on min suffix. There we go. Okay. So, yeah, I feel like this kind of falls on the slow side. I'm not really sure. I mean, these people are doing the same thing that I did, just with the min suffix, and then you just follow that same logic. So, yeah, I mean, this would be an O of n solution, right? Because here we make an O of n pass, and then we just make a second O of n pass. It's basically two passes, and you also have a stack. So, yeah, that's the solution here. I think, the thing with the robot and the thing with these operations maybe can confuse, at least it confused me a little bit, but, once you realize this is just a stack problem, it's not super hard. So, yeah.